So this is the deployments of DevOps Dave. You can see me in the corner. My name's Niall McMahon. I've been a developer at Unisquare for about 2 years now, and for the last maybe 9 or 10 months, I've been working on a project that's been very deeply involved with Kubernetes and Helm. And to be honest, just before the project started, I didn't really know much about either of them. I definitely didn't know about Helm. I'd heard a bit about Kubernetes and kind of had a rough idea of what it was, but I had no idea how I would even go about setting up a Kubernetes cluster or what exactly you could do and why it was better than just having a couple of different containers running. So I thought it'd be a good idea to put this presentation together and kind of go through a beginner level overview of what exactly Kubernetes is and what Helms is and what the problems they solve. Just as a bit of a disclaimer, like I said, this is a beginner level overview. This isn't a deep dive by any means. I'm not going to be going through the deep tips and tricks involved in setting up a Kubernetes environment. So yeah, let's get started. So this is Dave. He's the protagonist of our story. His name is Dave Stickman. He's a DevOps engineer at Stick Limited. And one day, Dave is sitting in work, absolutely flat out, as you can see. And his manager comes up to him and says, Dave, we've been working on a project for a couple of months now. Everything's looking good, but we need a dev environment set up. We need to be able to test this properly. So he says, do the deployment, please. And Dave says, yeah, no problem. I'll get right on that. So what exactly does he have to set up? So the project that he's been asked to set up has 3 separate components to it. The first is a React front end, just built using JavaScript with the React library. Second component is a Spring Boot backend, and the third component is just the database to store all the information. Luckily for Dave, these are all containerized, so Dave doesn't have to do any bespoke setup for these 3 applications. He doesn't care about the details of how React works or how Spring Boot works or how the database is set up. Doesn't care. He just has to load Docker onto the servers and run these images. So Dave does exactly that. He goes to AWS and he says, I'd like 3 servers, please. And Mr. Bezos says, yeah, no problem. And he conjures them or something or whatever AWS does in the back end. And Dave says, thanks, that's great. And he deploys the applications. And like I said, it's pretty straightforward. He deploys his Docker images and does a quick test, and everything's looking good. The 3 servers seem to be up and running. Everything's fine. But a couple of days later, Dave's enjoying his weekend, doing Dave things, and he gets a phone call from his manager saying, Dave, I'm really sorry to bother you at the weekend, but one of the servers has went down, the application's not running, I need you to go and take a look. So Dave has to stop what he's doing and go and do some server restarts and work out what the problem is, and kind of waste his Saturday doing stuff that he doesn't need to do. Another week goes past and Dave is again doing some Dave things, and manager calls again and says, Dave, I'm really sorry to bother you again, but this time the servers just aren't strong enough. There's too much traffic coming in, too many requests. We need more servers to handle this extra traffic. I think the QAs are doing load testing or something. So Dave has to leave again and cut his weekend short to go and add more servers to the system and maybe a load balancer in front of it. And this goes on and on. Every week, every 2 weeks, he's enjoying his weekend, then he gets a phone call saying, sorry Dave, there's a problem, I need you to jump on. So what is the problem that Dave's really having here? Well, he needs an infrastructure that is scalable in response to new demand. That is, as more traffic comes in, the infrastructure spins up more servers to meet the traffic. And he also needs an infrastructure that's fault resistant. That is, if an app crashes or something goes down or someone pulls the plug out or something, it needs to be able to spin up more servers in order to basically fix that fault. So what's the solution to this problem? Kubernetes. Kubernetes does exactly this, completely out of the box. It's the perfect use case for Kubernetes. But what actually is Kubernetes? Sometimes it's called K8s, and I'll be honest, I thought there was some sort of serious significance to the 8. Like, I actually found myself going back and looking at like the Kubernetes logo and counting the little spindles on the wheel and thinking, is there 8 there? And there wasn't, there was 7, and it really baffled me for a while, but it turns out there's literally no significance to it at all. It's just Kubernetes is a long word, and people don't like typing long words, so they replaced the Ubernetes bit in the middle with an 8 because it's 8 letters. And that's your fun fact for this presentation. But what actually is Kubernetes? It's an open source container orchestration engine for automating deployment, scaling, and management of containerized applications. And I'll be completely honest, I just took that definition off the website. What exactly does it mean? It's basically a tool for handling, having multiple Docker containers running at the same time. And but the reason I said Docker containers is because whenever we talk about containerized applications, we're almost always talking about Docker. I'm sure other programs exist to containerize your application, but Docker is kind of the industry standard at the minute. And I haven't heard of anyone using anything but Docker since I started doing this. And an instance of Kubernetes contains a Kubernetes cluster inside which Kubernetes resources are deployed. And we will get into Kubernetes resources a little bit later, but first of all, we need to get a Kubernetes cluster. So Dave, in this case, would go back to AWS and get an elastic Kubernetes service. It's supplied by AWS. It's one of the most popular ways to run your Kubernetes clusters. I think there are other ways. I think Google Cloud has some tools for this, and I think maybe Azure has some tools for this as well. But I've got experience with the elastic Kubernetes service, and anyone I know who set up a Docker instance or a Kubernetes instance has used this. Next step is installing kubectl. kubectl is literally just the CLI tool for Kubernetes. It's a quick download. You can get it off the internet. And the next step then after that is to kind of make those two things talk to each other. So take the configuration for your kubectl interface and configure it to run against the cluster that you've just created in AWS or Google Cloud or whatever. I'm not going to go through how to do all this kind of step by step because there's any number of tutorials on the internet and it would really bore you and I'm kind of bloat this presentation. So instead, I'm going to move on to what exactly Kubernetes resources are and kind of how they're defined. So for our use case here, the main Kubernetes resources that we're going to use are a service, an autoscaler, and a deployment. And these are pretty common Kubernetes resources. They're the kind of bread and butter resources. It's not an exhaustive list by any means. There's plenty of other resources out there. But these are the ones that you absolutely need to be familiar with if you want to set up a Kubernetes cluster. So how do we actually create a Kubernetes resource? I mean, it's fine saying what it is, but how do we actually make one of these things? And they're defined just using a YAML file. So you can just open a text editor, Notepad++, Atom, Visual Studio, whatever it is you use, and you'll just create the YAML file in your text editor. And then once it's created, you'll just use kubectl apply -f just to specify the file and just type in the name of your file. And assuming that your kubectl instance is configured to your Kubernetes cluster, that'll just deploy your resource. So the first type of resource that I want to run through is a deployment. So what exactly is a deployment and why do we use it? A deployment manages instances of your application. So you might have, 3 instances or 4 instances or 5 instances of the same application, all kind of splitting the same traffic and handling the load. And the deployment basically defines that. And they're contained in things called pods. Pods is another type of Kubernetes resource, but as long as you have a deployment set up, you don't really need to worry too much about setting up individual pods. A deployment will do that automatically. A deployment also defines the memory resource requirements for your application, so you can define how much RAM you want to allocate to this application, how much CPU, and all of that fun stuff. It also defines your template for how all your app instances should be created. So like I said, we're not setting up individual instances of an application. We're basically given the deployment information on how to do that. So you'll give it the Docker image for your application, your environment variables for your application, and the ports on which you want your application to run. And then, assuming everything's set up correctly, you can just specify how many instances you want, and your deployment will just spin up X number of instances of your application. So here is how you would define a deployment. using just a YAML file. And this looks pretty scary. There's quite a lot there, but to be honest, most of this is fairly boilerplate. You would just literally find an example deployment on the internet, copy and paste the YAML file, and sub in the details as you see fit. So we can see kind of the first component there is at the very top. We have a kind tag. We define our kind as a deployment. If we were deploying a service, we would define our kind as a service, and if we were deploying an autoscaler, we would define our kind as an autoscaler. So that's basically all that tag means, what kind of resource you're deploying. Besides that, we just have some basic details. We have the name of our deployment, we have the number of instances we want our deployment to start with, we have the Docker information associated with our deployment, or more broadly the container information, and we have the memory requirements like I mentioned, and we have the environment variables. And whenever we have all this set up and everything looks good, we would deploy this, like I mentioned, just using kubectl apply -f and then the name of your file. In this case, the file is just called mydeployment.yaml. And as soon as you do that, this deployment will immediately spin up on your cluster. So service is a good bit different. So like I said, a deployment kind of works directly to spin up instances of your application. Service doesn't really know anything about your application. A service is literally just kind of the front door for your application. It's the way in which external services will contact your application. So it provides DNS. It provides an internal DNS which other services within your cluster can access. But if you want to expose it to the outside, there's also like an optional external DNS. And the reason you kind of have both of these, and there's not just a single DNS, is if some of your services maybe are completely internal, maybe they're monitoring, or maybe they're database and you don't really want people being able to access your database from the outside, you can just have internal clusters or internal cluster domain names so that only other services within your cluster can access that. But if you have something that's kind of front facing, like maybe your front end or your website part or whatever, you can define an external domain name from which outside traffic can hit it. And the last component of service is a load balancer. So it allows you to just split up the traffic that's coming in between all of the different instances that your deployment has spun up, which is super handy, and you get that completely out of the box. So here's an example of a service. It's a lot more straightforward than a deployment. Like I said, it doesn't really have any information about your application. It is literally just the front door of your application. So again, we set up our kind at the start. Before it was a deployment, now it's a service. We set up the name of our service. We set up the name of our app, which is defined in our deployment. And we have some port information. Now this is actually kind of important. There's an important distinction we made here between port and target port. Port is the port from which external traffic will hit your service. So you might want it to be port 80 so that you can just type in your domain name and hit your service. The target port is the actual port on which your application runs. So for example, if your Spring Boot server runs on port 8080 or your front end runs on port 5000, this is where you would define that. And the service basically maps the outside port that users would use to the actual port on which your server is running, which is kind of more secure in a way in that it doesn't actually give people outside any information on your application in terms of what port it's running on. And again, if you want to spin up the service within your cluster, you just do the same command at the bottom, kubectl apply -f. In this case, it's my service rather than my deployment. So last component then is an autoscaler. And an autoscaler is really straightforward. It literally just defines two things. It defines the minimum and maximum number of app instances to run at any given time. So it'll look at your deployment and say, okay, how many are running? Does this meet the minimum number of app instances that we want running? And then it'll scale more up to match that if not. And it'll also define some criteria under which more app instances should be created. So you'll say something like, if the CPU usage of this app reaches 70%, then spin up more instances. And it'll continue to do that until it reaches the max number of instances that we've defined. I mean, we wouldn't want it just spinning up to infinity because that'll use up all your resources very quickly. This is the example YAML file for the autoscaler. You see, in this case, the kind is horizontal pod autoscaler. The name is just the name of the autoscaler, just call it my autoscaler. And the kind of bits that are important to this particular one are the minimum and maximum replicas, in this case 5 and 10. So it'll ensure that there's always at least 5 instances of your application running, and as and when it needs to, it will scale up to a maximum of 10. And we see at the bottom the criteria defined, which is the CPU utilization percentage. So once your CPU usage hits 70%, that's when it'll start scaling up your application up until that maximum of 10, like I mentioned. And again, we have that command at the bottom. If we want to deploy our autoscaler, it's the exact same command, just kubectl apply -f my autoscaler. So back to Dave. So his Kubernetes cluster looks very good now. He's got his 3 components set up. He's got his React front end, a Spring backend, and his database. And they all have their own collection of Kubernetes resources. They all have their own service, their own autoscaler, and their own deployment. And that's all looking really, really good. So Dave's been able to enjoy his weekends, and he's not getting bothered anymore because Kubernetes handles all of the problems just out of the box. But unfortunately for Dave, it doesn't really stay that way for long. Some time passes, about a year in this case, and Dave's just been adding wee bits and pieces over the course of the year. Every release there's been another microservice, there's been another Kubernetes resource, there's been some sort of change that needs to be made, and now his service looks really complicated. There's a bunch of different microservices, there's internal monitoring applications, there's CI/CD applications, whether it's Jenkins or TeamCity or whatever. There's a lot going on in his cluster now. It's not just as straightforward as it used to be. But that's fine. I mean, Kubernetes is still pretty good. As long as he's just managing that one cluster, it's fine. However, that doesn't really stay the case. Dave's boss comes up to him one day and says, Dave, dev environment's looking great. Everything's fine. You've done a really good job on this, but I need you to set up more environments just like this. So rather than just having a dev environment, we now have like a dev 1, a dev 2, a dev 3, a perf, UAT, prod, sit, whatever. So he has to set up like 6 environments now. So now his cluster starts to look a little bit different. It's not just one complicated cluster anymore, it's 6 complicated clusters. And every environment basically has the same Kubernetes resource files duplicated, only with kind of minor changes for the environment, as in like what Docker image it wants to use, or how much CPU the environment wants to use, or any number of differences between the environments. They also have their own scripts, which are again almost identical, just with kind of naming conventions changed. Rather than running the dev resources, it'll now run the perf resources or the UAT resources or whatever that environment needs. And like I said, this is a lot of duplication, and it's almost completely identical across all environments. So Dave's not particularly happy about this, but he has to do it. So now when his manager comes up to him and says, Dave, I'd like you to make a change, please. It's not just one change anymore, it's actually 6 changes, because there's 6 environments, which basically, as you scale up your environments, you scale up the work. So if you have 10 different environments, there's 10 different changes, and that's not really all that scalable. And not only that, as these projects tend to mature, these environments aren't really handled by Dave anymore. They might be handled by 4 different teams, all with their own level of access to their environment. So whenever Dave wants to make a change that's maybe a 10-minute change, it's not just him making the change anymore. He has to make the change, and then he has to go and tell the other teams to make the same change. So it has to be coordinated across the 4 environments, which isn't really ideal. And it can make a change, takes Dave 10 minutes or an hour. It can turn it into like 3 weeks. If, team number 2's guy is off that week, team number 3's guy just left and they're training up somebody else. And it can really push these changes far into the future. So it makes for just a very sad Dave. So here's the problem that Dave's facing now. He has multiple environments. His Kubernetes resources have been duplicated across those environments. The script to run every environment is pretty much identical, but just with name changes for the duplicated resources. Each change needs to be repeated 6 times, and it needs to be easy to replicate across multiple teams, because like I said, he needs to coordinate among all the teams for all of their different environments. So what's the solution to this problem? Helm. Helm is a Kubernetes abstraction tool, and rather than treating a Kubernetes cluster is like a collection of these different resources. It basically combines them into one entity. So now a cluster isn't a service, a deployment, an autoscaler. It's just a cluster. It's just one entity, and that's defined using a Helm chart. And so it basically allows us to define every Kubernetes resource once, and then sub in the details. It changes the details from being like a static command or a static literal to being a variable which changes per environment. And it condenses a Kubernetes script deployment into a single command. So before you might have like, I don't know, 20, 30 commands, all kubectl apply my resource, kubectl apply my next resource, and it'll go on and on. And for every new resource you add, you'll need to add a bit to the script. Whereas now, that's not a thing anymore. It can scan for all the resources in your cluster and just deploy them all in one command. So how do we actually build this? So a Helm chart is effectively identified by its directory structure. So a Helm chart is basically just, you can define it anywhere on your machine as long as the directory structure is correct, and it has a couple different components. So it has values files which are defined in YAML, similar to our Kubernetes resources. These allow us to define the values that change per environment. It has a templates folder for housing all your resource templates, and it has a chart manifest to name and version the chart. So this is a kind of overview of what that looks like. So you have the main directory there, which is just my Helm chart in this case. You have your templates folder that has all of your different Kubernetes resources. You have your chart manifest there in chart.yaml. Then you have your values files for all of your different environments. And at the bottom there, you'll see one that's just called values.yaml, and it's just like the base values that, you know, may change in the future at some point, so it's handy to have them in their own file, but will be the same across all environments. So here's the difference that it makes. So I've taken the deployment YAML that we defined earlier and shown the Helm equivalent. So you can see the name at the top isn't just my deployment anymore. It references a value in our values file. And depending on what values file you use, whether it's dev or UAT or prod or whatever, it'll sub in that value at runtime whenever you run the command. So it means that you don't have this duplication of a deployment for every environment. You just have this one deployment file, and it just uses the values file that you specify. And here's an example of a values file that we might define. So all the values we see here are contained in this values file. So now for every environment, rather than having 10 or 20 or 30 Kubernetes resources files all duplicated, all defined with a new script, we just have this one file that just contains the information that changes for each environment. So it takes a Kubernetes script that may look like this with all of our different environments, and it replaces it with one command. So now, rather than having to run a big bash script, you just run helm install, you name your cluster, in this case my cluster, and you tell it what values file to use. So if you're deploying to dev, you might use values dev. If you're deploying to production, you might use values prod, or whatever file you've decided. And once you've installed it once, you can then upgrade it after once you make changes. So for every change you make, you'll define it within your Helm chart, and then you'll just run Helm upgrade, and just name your cluster again and pass in the values that you want to use. So every release goes from a big bash script to literally one command using Helm, which is super, super handy. So now Dave doesn't have to coordinate between all his teams anymore. He can just make the change once, maybe make a pull request or something so that the other teams can have a look and sign off on it. And then they'll sign off on their change, and it's defined once, done once, and immediately done across all environments. So Dave isn't sad Dave anymore, he is now happy Dave. So just to sum up, having multiple applications and services within the same kind of application ecosystem can be really tricky. Kubernetes adds resilience and automatic scaling to your applications, so you don't have to do that manually. You're not Dave, you're not getting phone calls at the weekend to come in and kind of put out fires. Kubernetes handles all of that. However, Kubernetes resources, they can be tedious to replicate across multiple environments, and they can be a real pain to script. Every time you add another resource, you have to add it to a script, which can be easily forgotten, and it's very prone to human error. What Helm allows us to do then is to consolidate all of these resources into one entity, which is the Helm chart. We specify the values that change whenever we're deploying, and we do that just using a predefined values file for every environment, which makes it an awful lot easier. So hope you enjoyed that. If anyone has any questions, now is the time. Please let me know. Thanks.